All right, we good? How'd the homework go? Any issues? 1.3a? All right, thank you, Nate. Let us start. Why are you not clicking? There it is. Do a chapter review tomorrow and then chapter test. Homework tonight. 52 and 53 have an A through a G, I think. And of them all, 52 and 53 might need a little explanation. And we will get that explanation at the end of class. Good. All right, here we go. Continue on with this section called combinations of functions. This one will be 3 pre-calc sections in one class. Last class we did transformation. That was like half a chapter. Today we're gonna do operations with functions. That'll be actually the last thing we do, and then composite function. That's kind of where we start off with. Right? Should be a pretty easy class. So once again, do you remember composite functions? Do you remember operations with functions? Of the two, operations is the straightforward one. So an operation with functions plural implies operation with functions plural implies, let me help me out. There's multiple functions. So you can't just have f of x, you can't just have g of x, you have to have at least 2 functions. I don't think they give you more than 2 functions tonight for homework. So you have to have at least 2 functions, and then you're going to be doing operations. In math, whenever you hear the word operations, what does that mean? Math operations. There are 4 of them. What are the operations in math?
Addition, subtraction, division, multiplication.
Thank you. So the first one we're going to talk about is addition, and the hardest thing is simply the notation. As you look at that, it looks like it's an f plus a g times x, right? Isn't that what it looks like? When in reality, this is actually telling you to
find x.
No. Add f and g, right? Except f and g are both functions. So it's asking you to add f of x with g of x. It can also be written as f plus g as well, too. So you'll see all of those notations. You'll see the first notation, this one right here. That means I want you to do f plus g of x. That's function notation. Then function notation with a plus symbol between them. That one makes complete sense. No one's going to get lost on the middle one. And then this last one as well, too, probably no one's going to get lost. But the first one, this one right here, can kind of give you the impression you're taking whatever the value f is, whatever the value g is, and multiplying it by x. That is not what you're doing. Okay. What are we doing here?
Subtraction.
What are we subtracting?
G of x from f of x.
And the implied thing there is, I did not put that in the slide. This is taken directly from the book. The implied thing here is that, well, g of x could be more than just one number. It could be an entire function. So in reality, Abby, I'm putting brackets around g of x. In reality, what do you got to do with this minus sign?
Distribute it.
Distribute it to everything that makes up the g of x function. So if you want to put some brackets there around g of x to remind you that that minus sign needs to be distributed, do that. Shortcut method, f minus g. What's left? What's left? How about we do multiplication next? So this is your multiplication. This is take f of x and multiply it by g of x. Careful, quick note. Do you see what's between f of x and g of x? What is it?
A dot.
A dot? Yeah?
That means multiplication.
That means multiplication. Why am I saying this? What could it be mistaken for? What's the other one look like?
I don't.
Chase, what's the other one look like? Let me do it without shaking hands. What's the other one look like?
A decimal point.
No, but good guess. There's another thing that looks like a dot, but ain't a dot. What is it?
Oh, the circle.
The circle with the openness to it, right? We will be doing that today. That is composite function stuff. This is just take whatever f of x is and multiply it by g of x. What's left?
Division.
Division is the one you got to be careful with. Why do I say that? There is no issue with adding, subtracting, or multiplying, but there can be an issue with division. What would be the issue? It's division. Don't overthink it. What's the problem always with division?
Can't divide by 0.
You can't divide by 0. But remember, g isn't a value in the term in the sense of g equals a value. It's g of x. So you can almost always, unless it's a constant function, you can almost always get a 0 out of g of x. So when we talk about domains, you have to be very careful. And this is the one that causes problems on homework or tests. So math teachers always put a division one on because it's the one that requires the most thought. We'll see that here in a second. So it's f of x divided by g of x. G of x cannot be 0. These are the 4 that we'll have tonight for homework. These are the pretty straightforward ones. They're not too bad. Everybody good? Okay. There's always a but. And the but is they're going to not only ask you to do f plus g, they're going to ask you what is the domain. So now we got to do some thinking, right? All right, so let's see what this looks like. Well, there's no problem with adding f of x plus g of x. You take the two functions, you literally just add them together and simplify, cancel, cancel if you can, factor, all that jazz, cancel if it's a fraction. However, finding the domain is where the complexity lies. So here's how you do it. Well, in order to find the domain of the operations of the function f plus g, we have to consider each function separately first. So I'll first consider the domain of f of x. Let's say, suppose that it's a. A is going to represent the domain of f, either what x can be or what x can't be. You can say it either way. Then I will consider the domain of g, and I'll figure out what x has to be or what it can't be. Then I'm going to put those two answers together. If you remember when we did ands and ors on one of them, we did 2 number lines and we squeezed them together and we saw what the overlap was. You remember doing that with ands and ors before? Long time ago, algebra 2, algebra 1. Does that recall? Since I taught, at least Jason, I taught this too. And I know Miss Werewine used my slides. Does that strike a bell?
Vaguely.
You did a number line for the first one. You did a number lines for the second one.
Yeah,
And you kind of squeezed them together to see where the overlap was. That's what this is going to be, right? So I'm going to find the domain, and I'm going to use a funny symbol to show you what we're doing here. This is a, what does it look like?
An upside down U.
What does a regular U mean?
Union.
Union is the one where you want to use the entire 2 number lines put together. I want to use both of it. It's the union of the 2 number lines. So this is the opposite of this. This is
Or.
So this is called, we don't call this the or, but it's like that. This is going to be the intersection of the 2 domains. In other words, where the 2 domains overlap each other. We'll do an example if you're lost, but that means A intersect B. So if you're a little lost, let's do an example. Okay, so here's our example. So big picture, what are we doing here? Big picture, what are we doing? Taking f and I'm adding it to g. Well, that's the easy part. All right, Ben, add f and g. 2 minus 2x?
Or the root of that.
So tell me what you want me to write. If I just ask you to add f plus g, what do you get?
The root of 2 minus x plus.
Okay, I'm going to write that as the f first and then the g, but that works. Okay, so this is what it would equal. How come we can't combine these two together? Why can't I add the square root of x and square root of 2 minus x? Why can't I add those together?
Because there's a 2 involved.
If it said the square root of x plus the square root of x, could I add those together? Could I add these two together? So what would be the answer?
Root 2x.
Wrong. What would be the answer? It would be 2 root x, right? You can think of this as, I don't know, y. You can think of this as a y. Y plus y is 2 y's, right? The reason why we're allowed is because what's underneath the radical symbol is exactly the same. The radicand. So the only time you can add or subtract is when the radicand is exactly the same. What's 3 root x plus 5 root x? Okay. So this is why we can't do anything with that right there, because one is the square root of x, one is the square root of 2 minus x. If it was the square root of x plus the square root of x, we group together. Okay. Have we answered the question? Have we answered the question? We got to find the domain. And how did I say we're going to do this? Previous slide. How are we going to do this? Yep. So what are the steps? What are the steps?
You need to have A, B,
Okay. And A is
F of X.
the domain of f of x. Is it a sneeze or a chuckle?
Sneeze.
Okay. Ben thought it was a chuckle.
B is the domain of
I'm not
G of
laughing
X.
at you, Ben.
B is the domain of g of x. Okay. So here we go. What are we supposed to do?
Find the domain of F of X.
What's the domain of f of x?
Positive.
You just said all real numbers. And I slapped my face.
Oh,
And Jace is laughing at you for sure.
I'm very sour.
Well, look at what the function is. What is the function, by the way?
It's a root.
The root of x. When I say what is the domain, what is it really asking you?
With X goes from and to.
True, I would rather you say it something like it's what x either must be or what x can't be. So if it's the square root of x, what
Zero.
x can't be 0 because you can't take the square root of 0?
This can't be negative.
So what's the domain?
It would be from to all positive numbers. So
I'm not going to agree with that.
is it from 0 to infinity?
Okay, so write that. Interval notation.
So it'll be parenthesis 0, no bracket 0, comma infinity.
Okay, so that's my domain of f of x. Yes, everybody agree? That was kind of painful. Should we not pick Ben for the next one?
You should pick Ben.
Yeah, let's see if Ben has this figured out. Okay, what's the next step?
Find the domain of G of X.
I got to find the domain of g of x. So how do I do that? It's
But X
not.
can be negative.
So how do we figure out the domain? This was yesterday's class too, and the day before.
Would it just be all them?
There's a process to do this. What's the process if you have a square root? To find the domain.
Oh, you have to set it equal to 0, put it inside of it, right?
No, you're thinking about fractions. Fractions where you set the denominator equal to 0, and that's what it can't be. What do you do with square roots? Or fourth roots, sixth roots, or eighth roots?
Not taking the inside of them, saying too.
It's something about the inside, sure. But it's not setting it equal to 0.
You have to solve.
Help them out, Jace.
I would do it.
No, this is the only way you can do it.
Like, just think about it. Just any negative number, not 0 or 1, and then
Actually,
any positive number.
x could be any negative number.
That's what I originally said.
Yeah, but there's got to be a process to this. And yes, I've shown you this process, and no, you can't recall this. So maybe we should write this down so we don't forget it. There are two main things that we run into problems with: fractions and square roots. With fractions, you set the denominator equal to 0, 0 solved. That's what x can't be. What do you do with square roots? Greater than or equal to 0 and then solve. So what am I setting greater than or equal to 0?
2, 6.
So I set 2 minus x, set it greater than or equal to 0, and solve. Go ahead, Ben, solve it.
So x is less than.
X is less than or equal to 2. Did you say greater than?
Said less
I
than.
thought so. Where did that come from? Well, if you move the 2 to this side, then multiply by -1, it flips the inequality. Or if you add x to both sides, you can think about it either way. Okay, so what's the domain?
To be anything less than 2.
So how do I write that with interval notation?
So it'd be negative infinity to 2.
I didn't say yes or no. I'm just waiting for you to add something to that.
You want me to add parentheses in that?
Yes.
Okay, so parenthesis on negative infinity and then bracket on 2.
All right. Did everybody agree? So I've got the domain of F. I got the domain of G. Now I have to squeeze them together to figure out the overlap. This can be done in your head, but maybe it would help to do it with a number line, right? Okay, what's the number line for F? What's the number line look like for F?
0 and then an arrow,
Pointing.
positive.
Okay, so I'm putting Abby, I'm just doing a number line with 0 in the middle, and I'm shading to the right. There's F. What's G look like?
Open circle at 2. Or it's like closed.
You told me bracket. Everybody agreed. So the second number line starts at
2
2 in relationship to 0. Where's 2?
to the right of it.
To the right. So we'll call that 2. And you said
Closed circle.
closed circle shade,
Everything.
shade left. And intersection is where if I squish those two together, the shading would overlap. Where does the shading overlap? Okay, including 0 and 2 or excluding 0 and 2? Okay, so what's the interval notation?
Bracket 0, bracket 2, or 2 bracket.
Okay. It seemed like a lot of work and a lot of explanation there, right? I actually thought you guys would run through that very quickly, but it is what it is. All right. Do you need to see that again for the process? You need to see that again for the process. You sure? Okay. Did you guys beat Ben to the answer, or were you all as clueless as he was?
Beat Ben.
You sure? Okay.
He's got part of.
All right. To remind you, since that was painful, right? The two things that give us problems are square roots and fractions. What do we do with square roots? What did Addie tell us to do? Or find domain. What's the inequality?
X is greater than.
Whatever's on the inside, the radicand, you
Include.
know. How do you find it? What did Addie tell us to
Make it
do?
Inequality.
Yeah, but what is it?
X would be greater than or equal to 0.
You set whatever's underneath the square root symbol, the radicand, greater than to equal to 0 and solve. These are the 4 that you'll see. Okay? Set it greater than or equal to 0. Now I wrote x, but it could be like 2 minus x, or it could be x squared plus 4. It could be any of that stuff. What do you do with fractions? Define the domain.
Set it equal to
Set what equal to?
the bottom equal to 0.
Set the denominator equal to 0. This is what it can't be. For the square root, that's what it must be. It must be greater than or equal to 0. For the fraction, this is what it can't be. You can't have the bottom equal to 0. Nobody in the last class remember this. Do you remember the restrictions on logarithms for the a and the x? Do you remember that? Everybody, no one's trying to make eye contact because nobody remembered that. Just write it down. X has to be greater than 0. This number right here, the argument, that's the x value, has to be a positive number. So if you have a logarithm and it says, what is the domain? Well, whatever the argument is has to be a positive number. There are no restrictions on sine or cosine, but for tangents, so we have vertical asymptotes. We have vertical asymptotes on odd values of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, or -1, -3, -5. Tonight for homework, I took it easy on you and only gave you square roots and fractions. We'll come to the logarithm and the trig. I'm reminding you of these right now, but there's none of those tonight for homework. So when it asks to find the domain, and it's one with operations, well, you got to find f of x, you got to find g of x, and you're looking for the overlap. With one slight exception, which is the next example. Or maybe it's the example after that. I can't remember. Is everybody okay? All right. Yes, this is the one. All right. This is the one that will kick your butt. It will look very easy, and it actually has some complexity to it. So you really got to pay attention. Is everybody ready? All right, Jace, what do you see? What does it want you to do?
Divide.
All right, so divide.
X squared over x -1.
Anything cancel, reduce, factor?
No.
So that's it. You're done. You're done with half of it, right? I'm not saying it's always this easy, but in this case it was. The complexity for this one, fractions, has to deal with the domain. So make sure you listen, stay on every single word I say until we get to the answer. You ready? Same process as Ben do is what we do for this one. Okay, so what's the first thing we do, Jace? I gotta find the domain.
Yeah. Did the bottom first. And
Now let's do the top first. Because it does say f over g. So what's the domain of f?
all the numbers
So the domain of f is all real numbers. That was easy. Now what do you do?
at the bottom. Figure out what makes that 0,
Ooh, he's already thinking ahead.
which is
Really what you're supposed to do, what I just showed you is, we don't care about this first. We care about the domain of f. We care about the domain of g. What's the domain of g?
all real numbers.
All real numbers, which would leave you to the impression that the answer, if we do overlap, would be all real numbers. But as Jace quickly realized, we got a fraction. If this had been addition, subtraction, or multiplication, what would be the answer? All real numbers, right? There is no restriction on that. But because it's a fraction, or a square root, this one's a fraction, then we have to think this through, and we know, go ahead, Jace.
Give me 1.
The bottom can't be 0, so you're looking for the values of the bottom that would turn into a 0. So what would make it a 0? So if in the domain we let the x value be 1, we got problems. So the actual domain is,
All real numbers such that x is not equal 1.
I like that one. I didn't write it that one. I wrote it like this, but 100% what you just said. I didn't use intersection, I used union because there's two pieces that I got to use them both. But the way Jay said it, that's how I would probably put it. I think I put it this way because that's how they show it in the book. Okay, this is a medium one. We'll do a much more challenging one here that requires even more thinking. And I couldn't fool Jace. I fooled Ben, couldn't fool Jace. Does that make sense? We're only going to do a few of these. Ready to move on? Okay. Last one of these. Do you remember there's one other way to combine functions? We just combine functions using operations, add, subtract, multiply, and divide. There's one other way of combining functions. Do you remember?
It's the weird.
It's the weird open circle one. Here's the visual explanation. What's the function here? G. G is the machine. G is the function. So if I input X, what does it spit out?
Y.
More generally. a y, but if it's a function, we wouldn't say y, we would say g of x, right? It would spit out a y value, but since it's a function, we would call that g of x, yes?
Yeah.
What does a composite function does is it combines two or more functions. We'll only see two. What a composite function does is you got an input, which gives you an output, and what do you do with the output?
You put it in the.
You put it into another machine, and this machine's called f. Okay, smarty pants. What's the output?
F of G of X.
F of g of x. And this is why the first time you see it, it looks weird and you're not sure what's going on. This is a composite function. This is f of g of x. And a long time ago, right, people said there's probably an easier way to write this, and they write it with an open circle. So if you think of this as all just one big machine, it's not, it's two separate machines. But if you think of this as one big machine, then that's where this thing comes from. But here's the problem. What's the first machine? What's the first machine?
G.
Yeah, but when you write it, we read from left to right. Where's the first machine?
Second.
It's the second one. The second one, if you read it, is the first machine. The first thing that x goes into is the inside or the function on the right. Have I lost you on that? The first thing that the x gets plugged into is the second thing, or the inside, of the composite function. Okay, so write this down. What is a composite function? Given two functions f and g, the composite function f of g is defined by f of g of x, or we'd say equals f of g of x. And all this is showing you are the three ways this is written. That's all it's really saying. This is the three ways it's written. Either fog, F-O-G, except it's not an O, it's an open circle, or f of g of x, or, well, it's read the same way, f of g of x. So here's three ways of saying the same thing. Why do we need three ways? Really short way of doing it. The more complicated one that nobody remembers, and I'll just say the very last one is typically how you see it. Very good. Okay. Let's look at this in detail. These are the two ways you typically see it, like this, right? So for this one right here, you have an inside function. That's the g of x. That's the first thing that must occur. That's the first thing that x gets plugged into. Call it the inside function. And you got the outside function. The output of g of x is the input of f of x. Think about that picture of that machine I showed you. This says exactly the same thing. The g of x comes first, and the output of g of x gets plugged into the f of x. Make sense? Okay. I always say put the inside into the outside. One quick caution, right? F of g of x is not the same as this. You see the difference? You're going to have both of these tonight for homework. The one on the left means composite, one on the right means multiply. Boy, do they look alike. Boy, do they look alike. All right. So is this multiplication or composite?
Composite.
Open circle. How many questions are here?
6.
There are 2 questions. Which one do you want to do first?
F of G.
All right, let's do f of g. What do I grab first?
G.
G. What's g?
X minus 3.
G is x minus 3. So we're going to plug the inside into the outside. So the inside was, again, what's the inside? X minus 3. What do I do with that?
Plug it in the F of X.
I plug it into every x of the first function, or in other words, the f function. So everywhere there's an x in the f function, I'm going to write
X minus 3.
x minus 3. Well, there's only one. Well, that was easy. Except, do I need parentheses or not parentheses? I need parentheses. I need parentheses. So this would be parentheses x minus 3 squared. There you go. That was easy.
Yeah.
Okay, good.
Yeah.
What's g of f? Danny, what's g of f? What do I do?
X squared on the inside, x minus b on the outside.
So I take the inside, which you said was x squared, right? That's the inside. And
X minus b on the outside.
anywhere I see the value x of the g function, instead of x, I'm going to write x squared. Well, there's only one. So it's,
X squared minus 3.
thank you, Danny.
Hmm.
Stealing his thunder.
Take that thing.
All right, look at both of these and tell me something smart. Look at both answers, tell me something smart.
One has parentheses, one doesn't.
Okay. That's kind of smart.
That's good enough.
Look at both of them and tell me something smart. Are they equal?
No.
So are composite functions equal?
No.
Not always. They could be. If this was a constant function, f of x equals 1, and g of x equals 1, then what's f of g?
The same thing.
The same thing. That's only true for constant functions, right? But for most functions, f of g does not equal g of f. And that's the by the way here, right? For most composite functions, f of g does not equal g of f. All right, some practice. Who do we want, Addie? Which one you want, f of g or g of f? Do f of g for me. Inside, outside.
Square root of 4x minus 3.
Which would be
Square root
minus 2. Okay, so everywhere there's an x, I'm going to write 4x minus 3. Well, there's only one x. And then I simplify 4x minus 2. Yes. Kylie, g of f? Inside, outside.
plug in F into B.
So what would you get? There's your f.
Right. So 4 times that minus 3.
Yeah, and where's the minus 3? Inside or outside the square root symbol? So maybe I put parentheses just so I don't screw it up. You don't have to, right? But maybe I do just so I can show clarity. The minus 3 isn't underneath the radical. So make sense? Okay. So is there anything hard with composite functions? Not really. To kick it up a notch, they're going to ask one extra question. That one extra question is domain. Okay, this one is much more challenging than it looks like. By the way, it's the same thing as the previous one. It's much more challenging than the previous one. Okay, so let's cover the easy part. It just says find f of g. This is US. What's f of g?
Plug x plus 4 and root 2x minus 1.
Okay, what would you get?
Yeah. 2x plus 4 minus 1. But so
No. We're supposed to take g, what's the g value?
x plus 4,
And plug it into every.
x and f.
Okay, so what would it look like?
F root square root 2 in parentheses x plus 4
Oh,
minus 1.
minus 1. What would that simplify to?
2x plus 8 minus 1, so 2x plus 7.
Okay, there we go. So there is your f of g. Everybody with us? Now, once again, you really got to stay with me. This can be a slightly confusing. Okay, to find the domain, we do it the same way we did previously. What's the first thing we do? So you, Wes.
View is find the square root, so turn it into inequality instead of equal to
How about we find the domain of,
f of x.
let's find the domain of f of x. You were just jumping ahead. So let's find the domain of f of x. So how do we find the domain of f of x?
Instead of making inequality equal to 0, so
Greater than or equal to,
0.
greater than or equal to 0. So what do we write?
2x minus 1 is greater
Greater than or equal to 0, then
put the 1 on the other side, the
keep
negative
talking. So therefore,
2x is greater than or equal to 1.
therefore.
Divide by 2, so x is greater than or equal to 1/2.
So what's the domain?
Anything parenthesis infinity 1 half,
Where does it start?
it's the lower one, so bracket 1 half,
Ah.
C infinity.
There you go. So that right there. Yes, everybody? You gotta stay with me. You gotta stay with me.
All real numbers.
He's jumping ahead. So now we find g of x. What's its domain? And he said all real numbers. All right, now here's where the problem's going to occur. If you squeeze them together, the overlap is. You squeeze them together, the overlap is to infinity, but that ain't the answer. Think about how the machine works. What's the first thing you do?
Go through the
What's the very first thing you do? Think about the machine.
go through G and
I go through G, and what's the domain of G?
all real numbers.
So I plug in anything I want into G, but I take the output and
Put it in there.
And so here's the problem. If I take the value 1, do you agree that that's inside the domain of this? Is 1 in the domain of this? So if I plug in 1 for this, it should work. The issue is that there are numbers that don't work, and that is if I have an input that's less than 0.5. But G comes before F. G's going to give me all real numbers also as the range. So G is going to spit out all real numbers as well, not just the domain. Its range is all real numbers. So in that all real numbers, there are the numbers that are going to go bad for me. So the question is, what domains of G result in a range that gives me problem?
Anything not in that.
So how would I figure that out? This is a high level question here. What G values range are produced by an input that causes me problems with the input for F? I know what the problem for F is. It's 0.5 to infinity. So the question is, how does this function f of x, g of x, spit out a 0.5 or lower than a 0.5? That's my real question. Well, if my problem is lower than a 0.5, well, that's kind of easy to figure out. What should I do? I don't want G to spit out anything lower than 0.5. So I can figure out what that is. What values are going to spit out lower than a 0.5?
Anything lower than 4.5.
Close. How about we just set up the equation and solve it? What do we want this not to do?
Get a number lower than 0.5.
So shouldn't I make that the equation? So make that the equation. Inequality, I should say.
So x plus 4 is greater than or equal to 0.5.
That's what we would want it to be, right? I could also have made it less than 0.5, and that's what it couldn't be, right? Now we're simply going to solve this. Will tell us what it must be. So solve this.
X must be greater than or equal to 4.5.
Think that one through.
Subtract, so x must be greater than or equal to 3.5.
Greater than or equal to negative 3.5, because we're subtracting 4. Do you follow the logic? Is negative 3.5 in this domain right here? Heck no, but we know this is what's going to produce a 0.5. If I throw negative 3.5 into here, what do I get? If I throw a negative 3.5 into g of x, what does it produce?
0.5.
That's a good number, but anything
Less
smaller than negative 3.5, for instance,
2.5.
less than, not greater than,
5.5.
negative.
Negative 5.
How about a nice, easy, friendly number?
Negative 5.
How about negative 4, right? That's the first one, right? Negative 4. Plug in negative 4. What do you get here? So that spits out a 0. When you throw a 0 into this, into this, what happens?
It does work.
You get 2 times 0, which is
0.
and so you get the square root of negative 1, it falls apart, right? This is the challenging one, and this is the one that you will screw up. You will screw this one up. Because you really want to say, well, you push them together and that's the answer. So you got to think these ones through. The issue is always going to be square roots and fractions. If it's not a square root or fraction, then it's, you take the two domains and you squeeze them together and it's the overlap. Do you get the logic there? This was really a challenging one right here. Oh, what's the answer? Negative 3.5 to infinity. You pick any one of those numbers. Notice it's not this one at all. It's this one. Cool. All right. Last idea is this. Evaluating composite functions. This does not mean take f and multiply it by g and then multiply it by 1. What does this actually mean?
For X.
And then take that answer and plug that into f. Okay, so let's do that real quick. Wes?
X is 1, so 5, and you plug that in the square root 2x minus 1, so you get 10 minus 1, so 3.
He skipped a few steps, but he got it right. Yes. He didn't skip a step, he just didn't say the step. So we plug in g to the or we plug in 1, that's the x value, for the inside function, which is g. So we plug in 1 to g of x, which is x plus 4. 1 plus 4 is 5, and we get jump. Then we take that 5 and we plug it into the f function, the outside function. 2 times 5 is 10. 10 minus 1 is 9. Square root of 9 is back 3. And everyone's not paying any attention because they're like, oh, I got this. This is easy. Until it's not. Until we get to 52 and 53. You ready?
Sure.
So 52 and 53 look like this. It's the same question as this, except it's done either with a table or with a graph. Who thinks they're always the most clueless one in here? Wes, pick one, A through G. A through F, sorry.
D.
D, let's do D. Tell me what it's asking you to do.
Plug the g of 1 in
Plug 1 into,
x.
plug 1 into
G of X.
G. So G is the bottom one. 1 is the X value. So the top is your X value. So here's your 1. Plug that into G, and what do you get?
6.
We get 6. Now what do we do with that 6?
You
Plug
plug
it
it
into
into
G.
g. and-
Well, we plug it into the outside one, which again is G. But this is now not the Y value. This is now the X value. So now I have to go to
6.
6 and look at
3.
3.
Look down.
G, and that answer is 3. So the answer is 3.
So it's easy.
So it's
Well, yes, once it's explained, it absolutely is. Okay, I was hoping he didn't pick D because D is G of G. But I think you can handle the rest.
Yeah.
Except Jace doesn't have the I can handle it. So Jace, pick one more. F. Okay, so what are we picking?
6.
Picking 6, so we're plugging it into 4 or G. So I go to 6, I plug it into G, and I get 3. And then I take that 3 and plug it into F.
Right.
Except it's 3 now. So I don't go to 6, I go to
3.
3, and I look at
F.
F, and F is better?
Yeah.
Okay. The same problem now will be done with graphs. What time we get out of here? Right now? 35. No, we got 5 minutes. We're good. All right. So let's see how this one works. I don't know if you can see this on your sheet of paper or not very well, but you can see it on the board. Okay. Pick one, Addie. B. So we're going to do B. So what are we plugging in? The X value is 0 for what? F or G? F. F is the inside. So we're going to find X value 0 and look at what? F or G? F. F is the red one. So that would give you a Y value of 0. That's my new X value to plug into G. So we go to G, and that value is, yeah, 1, 2, 3. So the answer is 3. And I'll give you a hint. Everybody look up here. If you ever try to plug in a value to F that is smaller than 0, there's no red line there. So what would that mean? If I ever try to throw in a value lower than 0 into F, F is the red, what does that mean?
Undefined.
It's undefined. New fancy word, DNE. Ready? Ready? New fancy word. Does not exist. We like that in math. DNA means does not exist. If we ever try to throw a value of what into G, it does not exist. Look at the graph, look at the graph, look at the graph. If we ever try to throw a value into G that is greater than 4, 1, 2, 3, 4. If it's bigger than 4, you're over here, what happens? Works fine for F. There's nothing there for G. It stops right here. So therefore the answer is does not exist. And that's it. Good luck with your homework, and I'll see you tomorrow. I'm talking to Abby.